You will hear a number of different recordings, and you'll have to answer questions on what you will hear. There will be time for you to read the instructions and questions, and you will have a chance to check your work. All the recordings will be played once only. Write all of your answers on the test pages. At the end of the test, you will be given 10 minutes to transfer your answers to an answer sheet. You will hear a woman making a hotel reservation over the phone. First, you have some time to look at questions 1 to 4. Now we shall begin. You should answer the questions as you listen, because you will not hear the recording a second time. Listen carefully and answer questions 1 to 4.
Good afternoon, Grandview Hotel.
Yes, hello. I'm planning to spend a few days in your city next week, and I'd like to, make a reservation.
Of course. When did you want to stay here?
Next week, Wednesday night and Thursday night.
So that's February 13th and 14th.
Yes, that's right.
And how many guests will there be?
Just me. So, do you have a room available?
Yes, we do. I'll just need to take some of your information. May I have your name, please?
Oh, right, yes. It's Roxanne Wilson. Wilson.
Thank you, Miss Wilson. And may I have your credit card number?
It's 233-618-9872.
9872. Got it. All right, Miss Wilson. I have your reservation confirmed. Can I help you with anything else?
Before you hear the rest of the conversation, you have some time to look at questions 5 to 10. Now listen and answer questions 5 to 10.
Well, yes, I was wondering, since I'll have a couple of free hours Friday morning before I leave, is there anything interesting to see close to the hotel?
Do you like museums? The art museum's very close by.
I love museums, but not art. Can't stand it. I've heard your city has a very interesting science museum, though.
Yes, but unfortunately it's closed in the winter. Are you interested in shopping?
Sure, I love shopping. Are there any good stores nearby?
Yes, we have a large shopping mall just 2 bus stops away. You take the bus to Monument Square, and it's just half a block from there. Just look for the post office, and you'll see the mall entrance next to it.
Fabulous. What about lunch? I hear your city has good restaurants.
Yes, there's a nice restaurant very near. It's just across the street from the park.
Sounds good. I can have lunch, then walk in the park afterwards. I have one more question. What's the best way to get to the hotel from the airport?
Subway is the fastest, of course. There are buses, but they're quite slow.
I'll be arriving quite late, after 10 p.m. I thought I might have to take a taxi.
The subway runs until midnight.
Oh, good. Then I'll do that. Will there be someone at the hotel front desk that late?
Oh, yes. The front desk stays open until 2.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2.
Part 2.
You will hear a tour leader giving information about a bus tour. First, you have some time to look at questions 11 to 15. As you listen to the first part of the talk, answer questions 11 to 15.
Thank you for choosing City Tours. The reason so many people choose our tours when visiting this city is because you can design your tour to suit your own interests. Your all-day pass entitles you to board our bus at any stop and stay as long as you like at each place. The all-day bus pass costs $18 for adults. Children between the ages of 5 and 12 pay half the adult fare, and children under 5 ride for free. Our buses run every hour on the half hour, starting at 8:30 a.m. Our most popular tour is the Centre City Tour, which goes to all the major attractions in the centre of the city. From the starting point here at the tour bus office, the bus goes to the first stop, Hill Park. As you may guess, this park is located at the top of a small hill. The next stop is the fishing docks. Following that, the bus goes on to the third stop, Bay Bridge, located at the foot of the bridge which crosses the bay. The fourth stop is in the shopping district. Then the fifth and last stop is at Green Street.
Before you hear the rest of the talk, you have some time to look at questions 16 to 20. Now listen and answer questions 16 to 20.
There are many interesting things to do and see on the Centre City Tour. At the first stop, you can enjoy a spectacular view of the bay, the city, and especially of the fishing docks, which are located at the foot of the hill. At the second stop, you can walk around and look at the boats. Fresh fish from the bay is also for sale here, since this is the place where the fishermen bring in their catch. The next stop is where some of the city's finest seafood restaurants are located, so you might want to plan a lunch stop here. You can eat fresh fish here, prepared in the traditional local way. The fourth stop is, of course, where you can do your shopping. Don't miss the opportunity to purchase some of our city's famous handmade baskets. You'll want to take several home as souvenirs of your visit to our city. Finally, at the last stop on the tour, you can visit one of the oldest buildings in our city, the theatre. This building was built over 400 years ago and is still used today as a place to see plays, musicals and other performances, as well as our annual film festival.
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to Part 3.
Part 3. You will hear two students talking about their postgraduate research. Before you listen, you have 30 seconds to read questions.
Hey Marcus, how are you?
I'm really well.
I thought you were in South Africa.
I was until a month ago. I came back to do a PhD.
Do you know what you're getting into? I'm writing a master's thesis and it's driving me crazy.
Oh dear.
I heard you had an amazing job in a national park. Why would you give that up?
It's true. I started out working in a national park, looking after ostriches. And it did seem like my dream job. But almost by accident, I got involved in taking DNA samples from the birds. I ended up analysing the samples, myself, in a lab in Cape Town. It was incredible, working in the lab. Suddenly, I realised I had greater ambitions than being a park ranger.
Well, what was the DNA for?
You see, ostriches are part of a group of flightless birds called ratites. And there's a mystery in ornithology about how they spread around the globe when they can't fly.
That is weird.
There's one hypothesis that they originated in Gondwanaland, a supercontinent that moved apart from Pangaea between 200 and 120 million years ago.
Didn't Gondwanaland separate into Australia, Africa and South America?
That's right. Plus Antarctica and India. The theory is that ratites stayed on the drifting land masses, which would account for their present distribution. In the opposing hypothesis, borne out in the fossil record, ratites originated in the northern supercontinent called Laurasia. Then they flew south, but lost the ability to fly around 50 million years ago.
Which theory do you favour?
I'm keen on the Gondwanaland one because DNA analysis shows ostriches are the oldest of the ratites. And according to geologists, Africa broke away from Gondwanaland first. Also, DNA analysis of the extinct elephant bird of Madagascar and the kiwi of New Zealand suggests they're close relatives, so it's unlikely they became flightless independently.
But isn't the fossil record more reliable?
Not really. It's open to interpretation.
Before you listen to the rest of the conversation, you have 30 seconds to read questions 27 to 30.
How's your research going?
Not so well, I'm afraid.
I presume you're doing a master's in public health. What's the topic of your thesis?
Well, that was my first problem. It's changed about 20 times. Currently, I'm looking at fathers' visiting habits in neonatal wards.
Remind me how old neonatal babies are.
Up to 4 weeks.
And what's the aim of your research?
I'd like to propose a change to hospital policy. I think limited access by fathers to their newborns would improve the health of infants and their mothers, especially in intensive care.
Whoa! That's a radical idea. Letting the family be part of the birth process has been standard practice in hospitals for 40 years.
And because of that, I chose a quantitative research methodology.
You'll have to tell me what that is again as well.
Quantitative research collects data that can be explained numerically. It's used to determine general trends.
Uh-huh.
But my next obstacle was that I couldn't get a large enough sample of paternal behaviour to analyse it quantitatively.
Why not?
4 of the hospitals I approached refused me access to their patients. I did get permission from 2 others where I used to work, but the results of my survey were so scattered I couldn't model anything.
So, what did you do?
I opted for a qualitative approach. I gave up large data collection and did in-depth interviews with a handful of fathers. At the same time, I set up an online discussion group for fathers.
How did that go?
Frankly, it was too slow to be useful. I've got to finish my thesis by the end of the year, and managing the website took too much time.
Have you considered regression analysis? That is, determining the strength of the relationship between variables. It's used for things like trying to prove that video games lead to more violence among young viewers.
Yes, I have. In fact, I've changed supervisors, and my new one has guided me towards regression analysis. So, at last, I'm making progress.
That is the end of part 3.
You now have half a minute to check your answers.
Now turns to part 4.
Part 4. You will hear a lecture on searching for planets similar to Earth. Read questions 31 to 40.
For hundreds of years, people have wondered whether other planets could sustain human life. 20th century space missions cast doubt over colonization of our own solar system. But there's plenty of hope beyond. Distant bodies orbiting faraway stars are known as exoplanets. Since 1996, thousands of exoplanets have been found, most of which are massive hot balls of gas, like Jupiter. However, a new U.S. mission is focusing on smaller planets, 1/2 to twice the size of Earth. These must also be close enough to their star to be in a habitable zone. Today, I'd like to discuss NASA's Kepler mission, which began in 2009 and is ongoing. But first, who was Kepler? Well, Johannes Kepler lived from 1571 to 1630 mostly in what is now Germany. He was a physicist, astronomer, and optician. He was the first person to explain planetary motion correctly, and more importantly, he developed a way of working in which he sought to prove that theories must be universal, verifiable, and precise. This is known as the scientific method. I do think it is fitting that a tiny spacecraft is named after a giant of astronomy. NASA's Kepler satellite is small and relatively simple. Other telescopes, like Hubble, provide exciting data. But Kepler surveys just one area of the galaxy, the constellations Cygnus and Lyrae, and records events over several years. It has already identified around 1,000 new planets and provided data on another 3,000 potential planets. Kepler is powered by a solar array. Its largest instrument is a photometer, a sensor that measures the light emitted by more than 100,000 stars. The photometer is so sensitive it can detect a drop in brightness when a planet moves or transits in front of a star of 1 part in 10,000. This is like recording the decreased brightness of a car headlight when a small insect flies across it. When a planet transits, NASA's computers graph the curving light from the star. Regular, repeated dips in the curve could indicate a new planet. A smaller dip, when a planet passes behind its star, creates reflections. Scientists can draw conclusions about the planet's atmosphere from these reflections because, as Kepler knew, the laws of physics and chemistry are universal, even way out in space. For example, light is absorbed by different atoms at different wavelengths, so a light signature provides data on a planet's atmosphere. Hydrogen, carbon, oxygen, sodium, and other elements have been identified in new planets. However, the proportion of their composition is uncertain, making the detection of water difficult. But back to the Kepler data and some recent candidates for human habitation. In 2013, a star named Kepler-6 was found with 2 planets in its habitable zone. At first, these were considered similar to Earth, but on further analysis, each planet's mass was found to be several times greater than that of Earth. Their gravity might be strong enough to pull in helium and hydrogen gas, but this makes them similar to Neptune rather than Earth. The following year, a star called Kepler-186 came under scrutiny. Its 5th planet, known as Kepler-186f, seemed a more likely candidate. With a diameter of 14,000 kilometers, it is roughly 10% wider than Earth. It orbits close enough to Kepler-186 for it to be temperate, allowing water to flow at the surface. Smaller than the planets orbiting Kepler-6 Kepler-186f is more likely to have similar gravity to Earth's and a rocky surface, perhaps containing iron, ice, and liquid water. At the outer edge of the habitable zone, its surface may freeze, as it receives 1/6 of the light from its star that Earth does from the Sun. On the other hand, with a greater mass, Kepler-186f may have a thicker atmosphere, providing sufficient insulation. This has led astronomers to dub Kepler-186f Earth's cousin, not its twin. But I can hear you thinking, okay, there are planets out there that sound Earth-like, but can we reach them? Currently, no. In the near to medium-term future, afraid not. The only known man-made object to have left the solar system is the unmanned Voyager 1 probe. This happened in late 2013, and it had taken 37 years to travel from Earth. Voyager travels at around 61,000 kilometers per hour. Kepler-186f is about 500 light-years away. At Voyager's current speed, it'd take 17,400 years to travel a single light-year, or 8.7 million years for the journey from Earth to Kepler-186f. The Space Shuttle, the only speedy manned spacecraft, is far slower than Voyager, with speeds of just 45,000 kilometers per hour, meaning a 12 million year journey. Meantime, the Hubble telescope is investigating a suitable planet called GJ124b at a distance of 40 light-years away. But whether a planet is 40 or 500 light-years away is immaterial. Humans have always reached for the stars. Kepler the man and Kepler the spacecraft have raised the possibility of human habitation. Only our transport remains primitive.
That is the end of part 4.
You now have half a minute to check your answers.